F equals ma is quite useful because it helps you understand how F equals ma is used without any numbers or anything, just fully understanding. So it tells you a lift of mass m, so I'd always recommend drawing it out. So we have a lift of mass m. Let's change to a pen instead of a highlighter. M kg is suspended from a cable, so that means attached on top of it is a cable. Now, one thing you have to always know is that whenever there's a rope or anything connecting two objects like a cable, there's always tension acting on that. So let's label that tension capital T. That's actually what we need to find. The lift descends, meaning it goes downwards with a downward acceleration A, and a frictional force acts on the lift. Now, friction acts opposite to the direction of motion, so if it's going downwards, friction would act opposite to that, so upwards. We're almost finished label the forces, but there's also the weight of this mass that we have to take into account. Weight is just equal to mass times g, so we'll call this capital M g. And now we have enough variables to use F equals ma. The key thing to remember is F actually stands for resultant force, and the resultant force is the force in the direction of motion. Take away the force against the direction of motion, or forces against the direction of motion here. The force, because it's going downwards, the force in the direction of motion is the weight going downwards, mg, and we take away the forces that are opposing the motion, so that's tension and friction. So we take away tension and we take away friction, and then we make that equal to m times this acceleration a. It wants us to make tension the subject of the formula, so let's start by adding tension to both sides. So I'm just going to do the rest here. So we have mg minus f friction is equal to T plus ma, and then let's subtract ma from both sides, so we have tension, let's keep that on the right so you don't get confused, is mg minus ma minus f. Now let's compare this to the answers and see how they're similar. So it's definitely not this, because there's two m terms on the right hand side, but what we can see is that the m is being factored out, so let's do that ourselves. So we factor out m, and then it's g minus a, because m times g is mg and m times minus a is minus ma, minus the friction is equal to tension, which I believe is, yeah, option D. So that's the answer to this question. Hopefully that helps you understand how F equals ma, or Newton's second law, is used in calculations. Thanks for watching.